these coordinate systems are used to locate a point in a space to show a location actually. Okay. Okay. So here with respect to this origin, okay. Okay. Uh, this is one location. Actually, normally we call this vector location. Okay. This is normally called as vector location. Okay. Because these are, so these locations, so these distance are measured with respect to direction. Okay. So if you consider this location, it has a direction as well as a magnitude. Okay. So it is a vector. Okay. So normally this is referred as vector location. Okay. Vector location. Okay. Or position vector. So I think that is the real word is position vector. Okay. These are position vectors. Okay. These are referred as position vectors. Okay. So anyway, this is one position vector. This is another position vector. Okay. So there are two participles are there, Q1 and Q2. Okay. So this Q1 will generate a force on Q2 and Q2 will generate a force on Q1. That is described in Coulomb's law. Okay. In your A-level physics also you have learned this theory, but it is not in vector form. Okay. But here we are using the vector form. Okay. So this is that Coulomb's law in vector form. Okay. So this is a unit vector actually. This is a unit vector. This is referred as unit vector. Unit vector means uh, if the vector, any vector A divided by the magnitude of that vector, that is referred as unit vector. Normally we use a hat. Okay. For a unit vector, this is the notation I used. Okay. I used to um, this is the location I am familiar with. Okay. So maybe other notation may be used. Okay. So here this is a vector. This is a unit vector. That is that vector is divided by the magnitude of the vector. Okay. So that is the unit vector. So here you can see that. Okay. Vector is divided by the magnitude of the vector. Okay. So this is the unit vector. Okay. Uh, okay. So I think you can do these questions. Okay. Because answers are there, solutions are there. So maybe you can try to understand them by yourself. Okay. Uh, mm, so Dr. Udesh has done this example. Has Dr. Udesh done this one? Or shall we do this one? What do you think? I hope maybe you can do this by yourself. Okay. So it is not big fun. Okay. Okay. So we will go to the yeah, maybe here. Okay. So maybe we try to do this one. Okay. So we will try to do this one. Okay. Okay. So we will try to do this one. Okay. First. Okay. So here, uh, Here we have three locations. Okay, here we have three locations. Okay, here we have three locations. Okay, A, B, C. Okay, so here that location use the Cartesian coordinate. Okay, Cartesian coordinate or rectangular coordinate. Any problem?
Hả? Xe credit, xe credit. Em đang không.
Yeah, I will mute. Okay. Okay, I think yeah, now it is muted. Okay, I think mistakenly one student on his microphone. Okay, so I hope there is no problem. Okay, shall I continue? Okay, so here we are given three location A, B, C. I hope we are given it in Cartesian coordinate or rectangular coordinate. Okay, in rectangular coordinate we have x-axis, y and z-axis. So y, x, z. Okay, okay. So you have to use your right hand rule to uh, get this direction. Okay, so x direction is your thumbnail direction. X, y, yeah, thumbnail direction. Okay, and this is your y direction is the weathergill. No, damaragil. No, that is damaragil. I can't. I don't know what is the name. So your hand is like this now. This is the thumbnail, and there is another. Sorry, this is thumb finger. This is another finger. This is the middle finger, and here is small one. Okay, so this is your hand. Okay, and you have to use right hand side. Okay, so you have to use this. This is the thumb's nail, big finger for x-axis, and this for y-axis, and this is for z-axis. Okay, so using this direction, you have to get this direction. Okay, so I think again mute microphone is on. Yeah, okay, so be alert on your microphone. Okay. Okay. Anyway, I have muted it. Okay. So this is the x-axis, and this is y-axis, and this is z-axis. Okay. So in spherical coordinate, this is r theta 5 in spherical coordinates, and in cylindrical coordinate, this is please slide this. Okay. In cylindrical coordinates, this is O theta is okay. So using these nails, you have to get this directions. Okay. So anyway, okay. So anyway, this is XYZ coordinate. Okay. This is XYZ coordinate. Okay. And so one location is at A. Okay. So that is X is 1, X is 1, Z and Y are 0. So this is location A. Okay. And location B, X is -1, X is -1, this is -1, this is +1. Okay. -1, 0, 0. Then this is location B. Okay, so location C is x0, y1, okay, here 1, and z0. So this is C location C. Okay, so if I draw it, if I draw that location again, okay, we are focusing on this one. Okay, okay, so if I write, okay, if I draw it again, okay, this is Z axis, this is X axis, so this is Y axis, and this is Z axis. Okay, so your 1 point is here. Okay, your 1 point is here. This is X axis. Okay, your 1 point is here. Another point is here. So this is +1. This is -1. And your 1 point is here. This is A. This is B. And this is C. Okay. And here the Y axis value is 1. Okay. And you have 50 nanocoulomb 50 nanocoulomb charge at every location. So here you have a charge, I will write it as Q. Here also you have a charge Q. Here also you have a charge Q. That Q is equal to 50 nanocoulomb. Okay. 50 nanocoulomb means 50 into 10 to the power 12, no? -12, no? Nano means nano, yes, -9, no? -9. Yes, -9, thank you. Nano is -9 coulomb. So this is your charge value. Okay. So here you have Q, here you have Q, and here you have Q. Now you are asked to find the total force on it, on this charge, no? Total point on charge B. Total force charge at charge A. Okay, here. So you are asked to, due to this one, due to this Q, there is a force in this Q. That force is in this way. Okay. That is, let's say that force 1. And here, In this way also, you have a force. In this way also, you have a force. Okay. So that is, let's say that is F2. Okay. So you have to get the vector addition of F1 and F2. This F1 is a vector and F2 is the vector. So if you get the vector addition F1 and F2, okay. So I put this bar to emphasize this F1 is a vector, okay? Because this F1 is a force. Force has a direction as well as a magnitude. Okay. So F1 and F2, if you get the vector addition of F1 and F2, you can find the total F. This alternate, okay? Is there a D point? Uh, we are. Okay, there is another point. Okay, okay. Anyway, we will do this by this tool. Okay, otherwise we have to do very big simplification. Okay, maybe you can. Then we will find this using this three. Okay, so there is another charge actually at D. Okay, so that is here. Okay, here also you have a charge. Here also you have a charge. Okay, here also you have a charge. I'm sorry, I missed it. Okay. There is a D charge. Okay. That means this is a minus Y direction. Minus Y direction. Okay. So this is x-axis is 0. Y-axis is -1. That is here. -1. And Z-axis is 0. Okay. So your point is here. This is another Q. Okay. Actually, due to this Q also, there is a force. That force is like this. Okay. So you have another force actually, F3. Okay. So to find the resultant vector, you have to consider that one also, F3 bar. Okay. Are you clear? Okay. So if so maybe mm, I will, um, I will use another color. Okay. So this is point A. Okay. So that is 1, 0, 0. Okay. And this is point B. That is -1, 0, 0. Okay. This is point C. That is 0, 1, 0. This is point D. Okay. So that is 0, -1, 0. Okay. This is X, Y, Z. So here Y is -1. Okay. And you need to find the total force on this A charge. Okay. So here, all these 4 points, there are 50 nanocoulomb charges. You have to find the total charge on A. Okay. So you have 3 forces and you have to get the what is called the vector addition. Okay. So I think that is not much problem. Okay. That is not a big thing. Okay. So we will try to do this. Okay. So we will first consider one location. Okay. First we will consider one location. Okay. So when you are doing this, you have to consider the direction. Okay. You have to consider the direction. Okay. So shall I use the Z direction unit vector is Z hat, X direction unit vector is X hat, Y direction unit vector is Y hat. Shall I use like this? Or are there any notation? Another notation? මම මෙහෙම පාවිච්චි කරාට කමක් නැද්ද? මෙයාගේ unit vector එක Z hat, මෙයාගේ X hat, මෙයාගේ Y hat. හරි? මම දැක්ක පොතේ පාවිච්චි කරලා තිබ්බේ A1 2 like this. Okay, I don't know this. Okay. So that is the unit vector actually. Okay. So that is in another. Okay. Another direction. Okay. So you have to consider those directions when you are doing. Okay. So shall I use like this? Okay. So I will write that one. Okay. Maybe you can compare then. Okay. So here we have 1 coulomb. Here we have another charge. Okay. So total charge Q1, Q2. Okay. And this is related with the origin. This is related with the origin. Okay. This is related with the origin. නැත්නම් මේක පාවිච්චි කරේ AZ කියලාද? Have you used this AZ? Unit vector is AZ, AY, and AX like this. Let's see the book. Ah, yes, no, sure, no, okay. So I will use that one. Then maybe not. It may be a confusion. Okay. So I will use unit vector. Okay. Z unit vector is AZ. Y unit vector is AY. Okay. X unit vector is AX. Actually, this unit vector value is 1. Okay. Unit vector magnitude is 1. So this AZ just show a direction. හරි. ඒක චුට්ටක් තේරුම් ගන්න මේ AZ කියන එකේ value එක එකයි අතන magnetic එක. එතකොට එයාගෙන් අත්තටම පෙන්වන්නේ මේ unit vector එකෙන් පෙන්වන්නේ direction එක. හරි. AZ direction එක තමයි මේ unit vector එකෙන් පෙන්වන්නේ. හරි. AZ. Okay. So if you consider normal Coulomb law, okay, so this is the origin, and here you have a charge, here you have another charge, okay. So you need to find the force from this to this, from this to this, okay. So if this is, let's say that this is, this location is R1 and this location is R2, okay. Okay. So it is like this one, and like this, okay. Okay. So from here to here, there is another vector. That vector is in this direction. So this position vector is in this direction. This position vector is in this direction. Okay. So direction should be marked like this. Okay. So now you are going to find the force on this charge due to this charge. That is F. Okay. So F is defined as 1 over 4/5 epsilon naught epsilon R Q1, Q2 divided by this distance. Okay. So let's say that distance is R1 to this distance. Okay. This distance. Dura. Okay. This distance is R1. Okay. So you have to get R12 square. Okay. And there is a direction to this force. Okay. To this force, there is a direction. That direction should be denoted by the unit vector. Okay. So that unit vector should be in this direction. Okay. This direction unit vector. So it is denoted as A1. Okay. So this is the equation we are familiar. Okay. Now you have to understand this equation. Okay. This is a unit vector to indicate this direction. Okay. So this unit vector is in this direction. This unit vector is in this direction. Okay. Now let's consider this B this B cube Okay, this B charge, we will consider this B charge. Due to this B charge, there is a force on this uh, on this uh, on this A charge, no? Okay, so that force is, let's say that F1. Okay, so you can easily calculate F1, that is 1 over 4/5 epsilon R, epsilon naught, epsilon R, Q1, Q2. So this Q1, Q2 is 50 nano ohm and 50 nano ohm. Okay. So this epsilon naught and epsilons are normally given. Epsilon naught is 1. Okay. Uh, not 1, no, not 1. Okay. So anyway, this value should be given. Okay. So there is some data, these values you can get. Okay, so here we will not consider it. Okay, q1 plus q2, and this length, what is that length? What is this length? So here it is 1 minus 1, here it is 1. So from here to here the length is 1, from here to here again length is 1. So the length is 2, so we will have 2 square. Okay, the length is 2, so we will have 2 square into this direction unit vector. What is the unit vector in this direction? What is the unit vector in this direction? Tell me, what is the unit vector in this direction? So, yes, very good. Okay, that is the x-axis unit direction. So it will be x. Okay, so this is the answer. This is the answer for F1. Okay, so this is a vector. Okay, F1 is a vector. So you have found that answer. Okay, you have found that answer. Okay, then we will try to find another uh, another force. Okay, so we will consider this charge C. Okay, due to charge C, there is a force uh, in this charge, no? Okay, so I will write it here. Okay, so you have one charges here. Okay, so this is the origin. Okay, from origin you have one charge. Okay, so that is Q. Okay, wait a minute. Okay,